Hi, Gritsovs. Welcome back once again to our sessions. Thank you very much for joining us today. We are still continuing with analytical geometry, also known as coordinate geometry. And today we're going to be focusing closely on lines to a circle. That is tangent to a circle, or maybe secant to a circle, and problem related to that, connected to analytical geometry. Okay, so before we move really closely to that, let's start by doing a quick revision on the equation of a tangent to a circle. And this is one of the lines that you can see to a circle, right? A tangent, okay. And I'm sure we discussed a bit about this when we were doing Euclidean geometry, right? When we talked about tan-Cauchy theorem and also rad perpendicular tan theorem. Okay, so that knowledge is very, very important also in analytical geometry. Okay, so you must use a relational understanding approach in order to relate that knowledge in Euclidean also to coordinate geometry or analytical geometry. So we know that a tangent is any straight line that touches a circle at one point, right? If we have any straight line touching a circle at one point, we call it a what? We call it a tangent. Okay, and we can see from our diagram that ADB, can you see line ADB there, is a what? Is a tangent. Very, very important. AP is not a what? Is not a tangent. Why AP is not a tangent? We can see it cuts our circle or touches our circle at more than one point, right? So we call AP what? A secant. Okay, so this we call it a tangent because it touches a circle at one point. Okay, so a tangent to a circle at any point on the circumference is always what? It's always perpendicular to the radius at that point. Very, very important. If we have our circle with center O, we know that from O to D it's a radius, right? Where a radius and a tangent will meet, there will be what? Perpendicular. Remember that theorem, rad perpendicular what? Perpendicular tan from Euclidean geometry. Okay, so you must also be thinking about that because it's very, very important on question based on tangent to a circle in coordinate geometry. Okay, so we can also use all the formulae we know from analytical geometry to solve problems involving a tangent to a circle, right? It means that we can use those formulas such as distance formula, you can use midpoint formula, you can use gradient, angle of inclination, and the equation of a line, and also the equation of a circle. All these formulas that we have discussed thus far, they can be used to solve problems that involves tangents or secant to a circle. Okay, let's just go and take a look at how they can actually examine you on this. All right, let's take a look at this question very quickly. They say find the equation of a tangent APB which touches the circle center, a circle with center C with an equation. There is it, x minus 3 squared plus y plus 1 squared is equals to 20 at point P. Okay, so they want us to determine the equation of a tangent. Very, very important. To a circle, right? It means that it's very important that you just draw this circle just for you to have an illustration of what's happening here, right? It has a center what? C, right? And they want the equation of a tangent at point what? At point P on a circle. So we have this point P which is 5.3, right? And we have C, and C is the center of the circle, right? But we are given the equation of that circle. We know that from an equation of a circle we can deduce the center, right? So long as it's in standard form, or if it's not in standard form we can complete the square and actually make it to be in standard form and deduce the center. Okay, we can go and write our center there. Our A and B is gonna be what? 3. Remember, when it's negative you take it as positive. When it's plus 1, you're going to take it as minus 1. All right. So our center is 3 and minus 1. We can also deduce the radius. Okay. We can also deduce the radius. definitely radius is this line from C to P. Okay, but very important, we are very interested in this line called what? A tangent. We want to determine the equation of a tangent to this circle. Okay, what is the standard form for equation of a tangent? A tangent is a straight line, and a straight line is y equals to mx plus c. All right, mx plus c, where m is our gradient and c is our y-intercept. All right, so what we're gonna do now is, we know very importantly that a radius is always perpendicular to tangent. This is a key property that you must deduce when working with tangents and circles with radius and all that, right? So we know that that line is always perpendicular to the tangent. I mean, the radius is always perpendicular to the tangent. And what does it imply? It implies that when you take the gradient of CP and you multiply it with the gradient of a tangent, they must be equals to what? -1. Remember this property from analytical geometry. We know that if two lines are perpendicular, then the product of their gradients must be equals to what? -1. In other words, to solve the gradient of a tangent, we're going to use this property because we know that radius is always perpendicular to what? To tangent. Okay, that's our reason for saying when we multiply the gradients is -1. Okay, we're just going to calculate the gradient of CP, line CP, say y at C minus y at P over x at C minus x at P. All right, multiply by the gradient of a tangent is equals to -1. Let's go and substitute. Y at C is -1 minus y at P is 3, right? Is 3 over x at C is 3 minus x at P is 5, multiplied by gradient of tangent is equals to -1. We can simplify this part, right? -1 minus 3 is -4, and 3 minus 5 is -2, right? It's -2. Multiplied by the gradient of tangent is equals to -1. So -4 minus 2 is going to give us +2. Gradient of tangent, right, is equals to what? -1. Then when we solve for gradient of a tangent, it's going to be equals to what? It's going to be equals to -1 over 2. All right, very interesting. We have now calculated the gradient of a tangent using this property, because we know that radius is always perpendicular to tangent. We can now go and substitute back to our equation to say y is equals to -1 over 2x plus c. So for us to finally get the equation, we can just substitute any point that is within our line of this, within our tangent there, and we know there's point P, right? So I can come and say substitute P, which is 5 and -3 into the equation, right, for us to be able to solve for C. Okay, so this is x, this is what? This is y. Where there is y, we put -3. Where there is x, we're gonna put 5 and go and solve for C, right? Let me just delete this. Let's go and solve for C. So it's going to be -3 plus 5 over 2 when we transpose that, right? And that is our value of C, which is equals to -3 plus 5 over 2. It's -1 over 2. Then finally, our equation of a tangent, maybe let me write it in a different color. It's going to be y is equals to -1 over 2x minus 1 over 2. So this is our equation of a what? Of a tangent. Okay, so that's our equation of a tangent, and I hope you understood how it goes. Okay, let's just look at a different example. Okay, let's now look at another different example, quite similar but a little bit different. They want you to determine the equation of a tangent to this circle, x squared plus y squared is equals to 20 at a point 2 and -4, right? It's very important that you just make a small illustration for this. You want it at a point 2 and -4. you want the equation of that tangent, and you are given the equation of a circle x squared plus y squared is equals to 20. We discussed about this circle, and we said this is a circle that has as its center on the what? On the origin, meaning that its center is 0 and 0. Very, very important. So its center is 0 and 0. Then we can quickly go and determine what? The equation of a tangent, right? Using that property. We know that from center to a tangent, those two are what? Oh, sorry. Let me just redraw that quickly. We know that those two are what? Are perpendicular. Tangent is always perpendicular to radius. What does it mean? It means that if I let my center to be O, okay, I can just say gradient of radius multiplied by gradient of tangent. They will be equals to what? -1. Why? Because the radius is always perpendicular to what? To tangent. If two lines are perpendicular, then when you multiply their gradient, it's going to be equals to -1. Let's go and calculate gradient of tangent. So y at the center is 0 minus y at this is -4. Y at the circumference is -4. I just put in bracket there. Then x at the center 0 minus x at circumference is 2, multiplied by gradient of tangent is -1. This will give us 4 divided by -2, which is -2 times gradient of tangent. Gradient of tangent is -1. Then our gradient of a tangent will be -2, which is 1/2. Okay, so in other words, our equation for tangent will be y equals to 1/2x plus c. We need to solve for c. You just come and substitute that point on your tangent. Substitute 2 and -4. We know this is x, this is y. Where there is y, we put -4. Where there is x, we put 2. And we solve for c. 2 cancel 2. Then we have something like minus, okay, let me just put it on top. -4 is equals to 1 plus c. Then c will be -4 minus 1. -4 minus 1, which will be -5. Then we can finally deduce our equation of a tangent is y is equals to 1/2x minus 5 as our equation for what? For tangent. Okay, so that's basically how you solve those questions, and hopefully I hope you've now conceptualize this, and definitely you nail it if they bring it on your exam. Okay, let's take a look at quite a different one from these ones. Okay, so in this one, they want you to determine whether the line y is equals to x minus 5 is a tangent to a circle x squared minus 4x plus y squared is equals to 5. All right, so they want you really to determine whether that line is indeed a tangent. Okay, and what does it implies when a line is a tangent to a circle, right? The only thing that we can only predict, if this line is a tangent to this circle, we can say that it only have one point. There must only be one point of what? Of intersection between that line and the circle. Okay, so if a line is a tangent to a circle, we know that it only intersected one point, meaning that we must only calculate and we find that there is one point of what? Of intersection. Someone can say we can rather calculate the centers of this circle and calculate this gradient here. We must also find that this gradient is perpendicular to the gradient of that line, which is a tangent. In other words, when you multiply this gradient of radius and the gradient of radius and the gradient of tangent, they must be equals to what? -1. If they're not equals to -1, then that line cannot be a tangent. Okay, because we know that radius is always perpendicular to tan. So I'm just gonna choose the one that will be easier. I think it's this one for one point of intersection, because we don't necessarily need to go and get the centers, right, and complete the square and get the centers. You can use that approach as well, it's also fine, but we just prefer the one that is fast. Okay, so how can we do that? So we are saying if y equals to x minus 5 is a tangent to a circle x squared minus 4x plus y squared, which is equals to 5, then when we intersect these two, we must only get what? 1 point of intersection. That's all we are saying. Okay, so in other words, I can say this is my equation 1 and this is my equation 2. I'm just gonna substitute this equation into this, and I'm expecting to get to only 1 point of intersection if it is a tangent. Okay, so where there is y, we're gonna replace by what? By x minus 5 squared, because y is equals to x minus 5. There we go. We can expand that. It's going to be x squared minus 10x plus 25. If you take minus 5 to this side, it's going to be minus 5 is equals to 0. So it's going to be 2x squared plus x squared minus 4x minus 10x minus 14x plus 20 is equals to 0. If I take the common factor of 2, I'll be left with what? Or rather, if we divide both sides by 2, we'll be left with x squared minus 7x plus 10 is equals to 0. Okay, I think we can factorize this. X 5 times 2 is 10, 5 plus 2 is 7. So x equals to 5 or x is equals to 2. All right. Can you see that when you substitute that tangent into the circle, you are getting 2 points of intersection, x equals to 5 or x equals to 2. Can you see there are 2 points of intersection? We are expecting only 1 point, right, for it to be a tangent. Then we can now deduce that therefore that line is what? Is not a tangent. Is not a tangent. Why are you saying it's not a tangent? Because they are what? More than 1 point of intersection, meaning that that line is a what? Is a secant, because there are 2 points of intersection, and we know that a secant is a line that touches a circle at 2 points. So we are getting 2 values of x, meaning that there are 2 points of intersection, meaning the line is not a what? It's not a tangent. All right. All right, great stuff. Let's just do some quick revision with whatever we have covered so far in our analytical geometry sessions. Okay, this is what you need to be able to do so far. All right, we started with a revision from grade 10 to 11, where we focused on finding the distance between point on the Cartesian plane, and we use this formula, the distance formula, which says distance is equals to the root of x2 minus x1 squared plus y2 minus y1 squared. All right. We also use the midpoint formula to find the midpoint between 2 points on a line, using the formula x1 plus x2 over 2 point comma y1 plus y2 over 2. All right. And that is what? That is our midpoint formula. We also use the formula for gradient. Very, very important. We saw it upcoming as we were treating or rather solving these different examples, and also these different questions for tangent also in this session, where we saw that gradient is equals to change in y over change in x. All right, and you just say y2 minus y1 over x2 minus x1. We also focus on finding the equation of a line, right, using the gradient and y-intercept. The equation was y equals to mx plus c, right? And also you need to be able to know how to find the equation of a line using the gradient and the coordinate of at least 1 point on the graph, right? So you can use y minus y1 equals to m into x minus x1. So 2 points on the line, right? We first calculated the gradient and then substitute one of the point into the equation in order to solve for c, right? So that we can finally get our gradient. We also find the angle of inclination of a line using the formula m equals to tan theta as part of our revision. Gradient is equals to tan theta. And we did specify that if you find your angle as negative, you have to add what? You have to add 180 degrees, because we know angle of inclination is always positive because it is measured in an anti-clockwise direction. And all angles measured in anti-clockwise direction from the x-axis to that line, they will always be what? They will always be positive. Okay. And you need to be able to use the relational understanding approach to find other angles using Euclidean geometry, right? Using our session for Euclidean geometry, triangle, and all those things. We have covered it in Euclidean geometric session. So for your grade 12, we have also focused on determining the equation of a circle, right? We were focusing on that in our session 1 with radius r and a center AB, right? Where another circle is at the origin, where another circle will not be at the will not have its center at the origin. Okay. We also focused in this session determining the equation of a tangent, and also really focusing on finding the intersection between lines, right? I mean between circles and all that, right? You must also know the properties of triangle, isosceles, scalene, equilateral, right angle triangle. We focused on this when we were doing our Euclidean geometry. If you haven't watched that session, make sure that you watch them so that you have full knowledge on this. Also the properties of square, rectangle, trapezium, rhombus, and parallelogram. Okay, don't forget analytical geometry comes with plus or minus 40 marks in your paper 2. Okay, and that's all you need to know thus far. Practice makes perfect. Now you have to find those past papers and start answering those questions, okay, so that you can become perfect in this topic. All right. Otherwise, grade 12s, thank you very much for watching this session. Thank you very much for joining us in our session. Coming up next, we might focus on maybe helping you solve these past papers on analytical geometry. Otherwise, for today, that's all for me. Thank you very much for watching, and goodbye.